It is our great pleasure to extend a warm welcome to all our esteemed guests to the inaugural session. Welcome, sirs. We are truly privileged to have such distinguished personalities with us today, and we look forward to an enlightening and enriching session ahead. For the plenary talk in today's session, we have also with us today Dr. K.C. Mohite sir, Dean Faculty of Science, University of Pune, Professor Ghanashyam Bes sir, Department of Chemistry, Northeast Hill University, Nehu, Shillong, Professor Pranab Kishore Datta sir, Department of Electronics and Communication Engineering, Northeast Regional Institute of Science and Technology, Arunachal Pradesh, Dr. Amrit Pujari sir, Department of Science and Humanities, National Institute of Technology, Nagaland, and Professor Rakesh Ved sir, Department of Electronics, University of Jammu. We are honored to share that Professor Rakesh Ved sir has graciously inaugurated the seminar exhibition organized as an integral part of this international seminar. We extend a sincere and gracious welcome to all our esteemed guests to the international seminar. As we commence this international seminar, let us begin with the ceremonial lighting of the inaugural lamp, a symbol of knowledge, wisdom, and enlightenment. To do the honor, I respectfully invite the President of Governing Body, Jorhat Kendriya Mahavidyalaya, Dr. Deepak Sharma sir, to kindly grace the occasion by lighting the ceremonial lamp and marking the auspicious beginning of our event. I also invite respected Principal sir and all our esteemed dignitaries on the dais to kindly proceed for the lamp lighting ceremony. I request Dr. Gayatri Sutia Madam to help sir in the lighting of the lamp. Sir? Sir, here please. Yes, sir. Ceremony light.
Hello.
Thank you, sirs. May this illuminated lamp guide the seminar with the light of knowledge, wisdom, and innovation. We'd also like to inform that we have invited Honorable Vice Chancellor of Dibrugarh University, Professor Jiten Hazarika sir, and Honorable Vice Chancellor of Sivsagar University, Professor Mahadev Padgiri sir, and however, due to an emergent official engagement, they have expressed their inability to attend the seminar. They have conveyed their sincere apologies along with their best wishes for the successful conduct of today's program. We have also with us the media persons. I welcome all the media persons to our college. As a mark of respect and gratitude, we shall now proceed with the felicitation ceremony. At the very outset, I request Mr. Amar Bordle, Sir, Controller of Examination, Jorhat Kendriya Mahavidyalaya, to felicitate our respected Chairperson and Principal of the College, Dr. Dulen Soikia, Sir, with her traditional Assamese Fulam Gamusa, a selling sado, and to present a memento with a small gift as a humble token of our love and gratitude. Thank you, Amar Bordle, sir. Now I request Mrs. Jyotisikha Bora Madam, HOD, Department of Chemistry, Jorhat Kendriya Mahavidyalaya, to felicitate respected President of Governing Body, Jorhat Kendriya Mahavidyalaya, Dr. Deepak Sharma, sir, with her traditional Fulam Gamusa, a selling sado, and to present a memento and a small gift as a humble token of our love and gratitude. Thank you, Jyotisikha Madam. Now I request respected Chairperson and Principal of the College, Dr. Dulen Soikia, sir, to felicitate our Chief Guest and Inaugurator of the seminar, Honorable Vice Chancellor of Rabindranath Tagore University, Professor Manavendra Datta Chaudhary, sir, with our traditional Assamese Fulam Gamusa, a selling sado, and to present a memento, a small gift as a humble token of our love and gratitude. Now I request Dr. Rajan Bora, sir, Vice Principal, Jorhat Kendriya Mahavidyalaya, to felicitate keynote speaker, Professor Vijaya Srinivasu Vallabha Purapa, sir, from Department of Physics, UNISA, South Africa, with her traditional Assamese Fulam Gamusa, a selling sado, and to present a memento, a small gift, and a humble token of love and gratitude. Thank you, Rajan Bora, sir. We have also with us Professor Rakesh Ved, sir, and Dr. K.C. Mohit, sir. I warmly invite them to the dais. Welcome, sir, to the dais. Welcome, sir. Now I request Mr. Rajiv Bordle, sir, Academic Vice Principal, Jorhat Kendriya Mahavidyalaya, to felicitate special guest of honor, Professor Ranadhir Chakravarti, sir, from Department of Biotechnology, North Bengal University, with our traditional Fulam Gamusa, a selling sado, and to present a memento, a small gift, as a humble token of love and gratitude. Now I request Dr. Panchali Karmaka, Madam, HOD from the Department of Zoology, to felicitate Dr. Rakesh Ved, sir, with our traditional Assamese Fulam Gamusa, a selling sado, and to present a memento, a small gift as a humble token of our love and gratitude. Thank you, Panchali Madam. I now request Dr. Gayatri Sutia Madam to felicitate Dr. K.C. Mohite, sir, with her traditional Assamese Fulam Gamusa, a selling sado, and to present a memento, a small gift as a humble token of love and gratitude. With this, we conclude the felicitation program here. Now, moving forward, I invite Dr. Sevali Saikia, Head of the Department Mathematics and Coordinator of the International Seminar, to briefly present the objectives and vision of the seminar before this August gathering. Welcome, Dr. Sevali.
A very warm good morning to respected chairperson, honorable chief guests, honorable dignitaries, distinguished delegates, faculty members, research scholars, and dear students. It is indeed an honor and privilege to welcome you all to the NEC and CSIR-sponsored International Seminar on Convergence of Nanotechnology, Biotechnology and Artificial Intelligence, Nano-Bio-AI, Innovations for Environmental Sustainability and Smart Societal Solutions, organized by Science and Technology Forum, IQSC, IIC, Jorhat Kendriya Mahavidyalaya, in collaboration with the Department of Biosciences and Bioengineering, Institute of Technology, Guwahati, Northeastern Institute of Science and Technology, Jorhat, and Rainforest Research Institute, Jorhat. Knowledge is the foundation of progress, and research is the driving force that converts ideas into meaningful solutions. Today, we gather here to celebrate the transformative power of knowledge and research in shaping a more innovative, inclusive, and sustainable future. The primary objective of this international seminar is to create a dynamic platform for scholars, researchers, and professionals from across the world to come together and deliberate on emerging trends, pressing challenges, and innovative solutions within the field of nanotechnology and biotechnology for sustainability, environmental challenges and pollution mitigation, artificial intelligence and smart technologies, climate resilience, energy and sustainability, indigenous knowledge and traditional practices, policy, community, and interdisciplinary perspectives, etc. Through shared perspectives and academic exchange, we aim to strengthen both theoretical and practical applications that can contribute to the advancement of the Northeast region and the progress of our entire nation. As a part of this initiative, one of the enriching and insightful components of this seminar is the poster competition, which encourages our young researchers and students to display their creativity, originality, and scientific thought. It provides a wonderful opportunity for them to present their research ideas in an accessible format while receiving valuable insights and feedback from experienced experts and academicians. In addition, we have organized an exhibition that serves as a bridge between knowledge and implementation, a platform where academia, industry, and students of the college come together. At this moment, I would like to acknowledge the collaboration that has made this seminar possible. This joint initiative of Jorhat Kendriya Mahavidyalaya in collaboration with the Department of Biosciences and Bioengineering, Indian Institute of Technology, Guwahati, Northeastern Institute of Science and Technology, Jorhat, and the Rainforest Research Institute reflects a shared commitment to academic excellence and cooperation, strengthening our academic community and expanding opportunities for meaningful engagement. As we formally inaugurate this seminar, we convey our deep gratitude to our respected principal sir, esteemed collaborators, distinguished guests, resource persons, and participants for their invaluable contributions of time, effort, and expertise. Let this seminar to be more than just an event. Let it be a journey of idea, collaboration, and inspiration as together we commit to advancing knowledge, empowering the next generation of researchers, and building a future founded on cooperation and shared learning. Thank you, and I wish this seminar to begin success with the active cooperation of all of you. Thank you once again.
Insightful address. With the objective of the event clearly outlined, I now have the honor of inviting our respected chairperson and principal of Jorhat Kendriya Mahavidyalaya, Dr. Tulen Soikia sir, to kindly deliver the welcome address. Sir, we look forward to your inspiring words and valuable insights for this enriching international seminar. Welcome, sir.
Good morning and warm welcome to all of you present in this international seminar. Respected dignitaries on the dais, respected President of Governing Body, Jorhat Kendriya Mahavidyalaya, Dr. Deepak Sharma sir, respected chief guest of this international seminar, Professor Manavendra Datta Chaudhary sir, Vice Chancellor Rabindranath Tagore University, Hosai, Assam. We have invited sir to deliver the inaugural speech. Sir has accepted our invitation, and he is with us in this inaugural session. We are very grateful to him. We have invited Professor Vijaya Srinivasu, Department of Physics, University of South Africa. He has also accepted our invitation. He is joining us in this international conference. Thank you, sir, for your presence in this seminar. We have invited Professor Randhir Chakraborty, Senior Professor, Department of Biotechnology, North Bengal University, as a guest of honor. We have invited Professor Rakesh Bhaid. He is one of my very good friends. He is coming from Jammu, the University of Jammu. So far he has visited 3 times this institution. Thank you for your coming the way from Jammu. My another friend, Dr. K.C. Mohite, is coming from Pune, Dean Faculty Affairs, Pune University. He is also the principal of C.T. Bora College. Thank you for your coming to this conference. We have invited Professor Pranab Kishore Datta, Department of Electronics and Communication Engineering, Northeastern Institute of Science and Technology, Arunachal Pradesh. He is also joining us in this conference. Thank you for your presence in this seminar. We have invited Amit Pujari, Associate Professor in Chemistry, Department of Science and Humanities, National Institute of Technology, Nagaland. He is also joining us in this conference. Thank you, sir, for your presence in this international conference. We have invited other resource persons, my friend Deepika from Royal Global University, all the respected faculty members, guests, students, media persons, both electronic and print media persons. They have also, we have given invitation to the media person in this conference. They are present in this seminar. Thank you very much for your presence in this seminar. At the very outset, I would like to offer my proud privilege and great pleasure and a very warm and heartfelt welcome to all of you for joining this international seminar on convergence of nanotechnology, biotechnology, and artificial intelligence. In brief, it is known as Nano-Bio-AI. And innovations for environmental sustainability and smart societal solutions, hosted by Jorhat Kendriya Mahavidyalaya and the IIT Guwahati, the Biotechnology Department, IIT Guwahati, CSRNS Jorhat, RFRI Jorhat, and it is sponsored by NEC and CSIR. The theme of the seminar reflects the direction in which the modern science is moving. Question arises in our mind, why the convergence of nanotechnology, biotechnology, and artificial intelligence, which is together known as Nano-Bio-AI, is so important today. That is a big question, and that is the main theme of this conference. The answer lies in the nature of challenges we face. Issues such as climate change, sustainable energy, public health, food security, and smart urban living are becoming too complex to be solved by a single discipline. Nanotechnology provides advanced materials, and sensors. Biotechnology offers life-inspired solutions, and artificial intelligence brings powerful data-driven intelligence, a new scientific ecosystem that is capable of delivering integrated and scalable solutions. Around the world, so this convergence of nano-bio and AI is already shaping some real outcomes. In Europe and United States, AI-enabled nanosensors are being deployed to detect pollutants in air and in water in real time, helping the government respond faster to the environmental risks. In Japan and South Korea, bioengineered nanomaterials guided by machine learning models are accelerating early disease detection and personalized medicine. In the field of agriculture, AI-assisted nanofertilizers and bio-based smart delivery systems are improving crop productivity while reducing chemical waste and supporting both food security and environmental protection. So these global examples demonstrate that Nano-Bio-AI is not merely a scientific development, but it is going to benefit the common people and the society at large. The National Education Policy 2020 encourages higher education institutes to become hub of research, innovation, international collaboration, and this seminar brings together experts from across the world to discuss these ideas and find ways to turn research into practical solutions for society. And this seminar has been carefully planned around some of today's most important research and policy priorities, including sustainability, energy transitions, innovation and startups, advanced materials, technology-driven development, and the role of higher education in improving research, employability, and access to the quality education. For Assam and Northeast, the topics of this seminar are particularly relevant. The region, basically, this Assam and the Northeast region has the potential in renewable energy, environmental sustainability, biodiversity, agriculture, and local innovations. By combining our local strength with global research, we can develop solutions that are both practical and sustainable. At Jorhat Kendriya Mahavidyalaya, we are working to become research-oriented and innovation-capable institution through IQAC-led reforms, through institution innovation councils of Jorhat Kendriya Mahavidyalaya. Many startup initiatives are being taken. We have virtual labs, skill-based programs, and interdisciplinary research. And we are aiming to turn advanced science into real benefits for the society. At Jorhat Kendriya Mahavidyalaya, innovation and research are at the heart of our mission. As a regional nodal center for virtual lab, we are offering students and faculty the advanced experimental platforms for hands-on learning and research. Our innovation and incubation centers nurtures idea into real-world solution, giving rise to products like Rhino LED bulb, ethically green tea, Rosile and Cleanile floor cleaners, Kirkimito vermicompost, and a waste paper recycling unit. We also provide services like energy audit, green audit to the various higher education institutes. So far, we are providing this green audit and energy audit services to as many of 20 colleges in this part of the country. In our research, our team is advancing flexible electronics, working on conducting inks, and coppered up ZNS transparent conducting films for next generation optoelectronics applications. So these reports reflects our commitment to sustainable innovation, practical research, and entrepreneurship, empowering students to become future problem solvers and leaders. I hope the discussion in this seminar will lead to a strong research collaboration, new publications, projects, lasting partnerships. More importantly, I hope it will inspire young researchers and students to explore frontier technologies ethically, responsibly, and sustainably. We are very grateful to the partnering institutions, also the professors joining from various universities outside India. Professor Hemanta Dule, he'll join us this conference online. He is the Associate Professor, Melbourne University. Dr. Debobot K. Bora is the University of Guria Morocco. Dr. Utpal Bora, Professor and Head, Department of Bioscience and Biotechnology, Indian Institute of Technology, for collaborating with this institute, this seminar. I once again offer my sincere welcome and gratitude to all the invited research persons, guests, dignitaries, participants, media persons, faculty members for participating in this seminar and making this international seminar a success. Once again, I warmly welcome and our distinguished delegates, and wish this seminar a grand success. I also offer my gratitude and thanks to the organizing team for making this seminar successful and making this seminar bringing to the face. And with these words, once again, I welcome you all to this international seminar. Thank you very much.
President, governing body of this college, the chairman of this inaugural session, honorable principal, respected other luminaries sitting on the dais, luminaries sitting off the dais, my esteemed colleagues, my dear students, media friends, ladies and gentlemen. I feel honored that I have been invited to attend this conference, this international conference, and I was given a chance to act as inaugurator of this conference. While I was invited to attend this conference long back, probably 3-4 months back, I was not interested to look at the content of the conference. I just looked at the intent of the organizer with which they invited me. Particularly, one of the members of the organizing committee, Dr. Binod Hajarika. 25 years back, he was a student of Assam University. He was the first boarder of the first hostel of Assam University, and I was the first warden of that particular hostel. I still remember that first night, he was the only boarder staying in the lonely campus, in the lonely hostel, and I was the only warden. These two living persons were there in that night in the hostel. I still remember. I was wondering how the respect of a student for a teacher remain intact even after 25 years of detachment, because after that, I didn't have any connection with Dr. Binod Hajarika. But suddenly, I got a call from him last year. There was a seminar last year also, he said, "Sir, you will have to come." But it was not possible for me to come because we had convocation there. And after the convocation, we had Northeast Folk Festival last year in 2025, so I could not attend. This year also, again, I got invitation from Dr. Binod Hazarika, and I gave him a commitment that I will be here, although we had convocation yesterday. We finished the convocation. Our Chancellor, His Excellency Honorable Governor was there. We finished the convocation. Immediately after convocation, we had again Northeast Folk Festival up to 10 o'clock at night. And this morning at 4 o'clock, I started from Hojai to reach Jorhat to attend this conference, just to honor the respect of a student for his teacher, which remain intact after 25 years of detachment. I was listening the distinguished names and designations of the distinguished dignitaries who have been invited to attend this conference, and I am sure with their presence, the seminar will be a vibrant one. So I thought I should not speak much on the theme, because as you know, I was discussing with Srinivasuji. I got introduced to him, that after assuming the charge of administrative responsibility, you see, you cannot perform dual role. So gradually, I'm getting detached from the academics and research, focusing more on administration, knowing fully well that this is not a good job to remain busy with administration only, because it doesn't give you any pleasure. Basically, we are teachers, we get pleasure from teaching and research. But again, the situation compelled you to remain involved more and more with the administration. But what I understand, the topic of this seminar is a divergent one, and from that divergent field, some sort of convergent will be searched here. Convergent towards sustainability, environmental sustainability, convergence towards smart societal solution by converging almost three diverse fields like nanotechnology, biotechnology, and artificial intelligence. Well, my name was announced. So far as my background was said, it is mentioned that my field is computational biology, and I used to do computer-aided drug designing. I have good connection with Professor Ranodhir Chakraborty. We have long association. We have a society also, and with that society we organize national and international conference in many places. Our collaborative organizations are IIT Guwahati, IIT Delhi, like many other, North Bengal University, Dibrugarh University, Assam University, Benares Hindu University, NEHU and all. What I understand is that because I was involved in computational biology, I got the opportunity to serve Government of India as a member of Department of Biotechnology, Government of India Task Force, which is the funding body so far as the computational biology is concerned. And that computational biology is linked to artificial intelligence also. But my observation, it was a 3-year tenure, my observation from that responsibility is we get huge number of proposals for evaluation, for recommendation for funding. But I used to, because I am from the Northeast, so always I compare how many proposals are from the Northeast. But it's a matter of sorry that from the Northeast, comparatively very few proposals we received so far as the artificial intelligence and biotechnology and bioinformatics are concerned. So my humble submission to all the researchers here, the teachers, researchers from different institutions, whenever there will be a call for DBT, I am not a member now, so I can tell you now. So whenever there will be a call for DBT, please submit your proposal. Even tomorrow is the last day for one call for establishing bioinformatics center. The last date has been increased. So you can you can just submit your proposal, establish a bioinformatics center in Jorhat, Kendriya Mahavidyalaya. Only in that case, the research will be enhanced, so far as the undergraduate colleges are concerned. There was a time when DBT used to fund for Biotech Hub, but now that project is stopped. So the Biotech Hub served a lot for undergraduate students. I understand, we have evaluated that, the progress of the Biotech Hub. But now the policy has been changed, very few Biotech Hubs are there. We had 28 bioinformatics center in the Northeast and 176 bioinformatics center throughout the country. Now again, because the government changed the policy, almost all the bioinformatics centers were closed. Now again, Government of India has taken initiative for introducing some new bioinformatics center in some of the institutes. So this is high time, my dear colleague. If you are interested to have computational biology related research, please look at the DBT e-Promise portal, because now you will have to submit the proposal online. You see the DBT e-Promise portal, do the registration for Jorhat Kendriya Mahavidyalaya and submit your proposal. Maybe your proposal will get through and you will get the funding. This is a 5 crore funding for 5 years, huge funding. And with that fund, Jorhat Kendriya Mahavidyalaya can develop a very good bioinformatics laboratory. And when there will be bioinformatics laboratory, easily you can combine biotechnology, you can combine artificial intelligence. My dear students, in any higher education system, there are three basic components. One is knowledge propagation. As teacher, we initially propagate knowledge, teach in the classroom. This is knowledge propagation. The second component of higher education is knowledge creation, for which the research is required. If there is no research, there will not be any knowledge created. Of course, the third step is knowledge, making knowledge work. The created knowledge should work at the level it should. Now, if we look at the output of the research, there may be two different types of output. For social science and humanities, the output may be an idea. For science, it may be either an idea, either a product or a process. Now, the reflection of the idea may be publication of a paper. Reflection of that idea is maybe in the form of this type of seminar. So far as the science is concerned, the reflection of the output may be again in the form of this type of seminar or publication or the patent. Nowadays, the funding agencies are giving emphasis on product-oriented research so far as the science is concerned. They will give you a target and then you will have to give the output. But again, and the demand, if you have any patents out of the project sanctioned. Now there was a time when even for the promotion of teacher, publication used to be given credit, but there was no credit for patent. Now it is introduced. The UGC has revised the system. For patent also, there is a mechanism of giving credit. But my dear students and researchers, getting patent is not the end of the story. The ultimate objective is that your patent should get licensed and the product should appear in the market so that your institute and you can get some financial benefit out of that. Then only getting your innovation patented will be successful. So my humble submission to all present over here, particularly the young researchers, will be try to grab the opportunities given by the funding agency, get more and more funding, establish laboratories, and then you try to go for product-oriented or the process-oriented research, which the country is demanding at the moment. For that, your project should be innovative. Sometimes it is misunderstood that innovation is something very big thing. It's not at all. Some very small work may be an innovative work. So the basic key for designing an innovative project is to think out of the box. What the other people are thinking, you will have to think in a different way. What the other people are thinking for a solution to a problem, your thinking should be something different. And if your thinking is ultimately proved correct, then that is your innovation. So a small investigation may be innovative, but a very big investigation, very big research project may not have any innovation. So before you start your project, my dear young researchers, please look at whether your work is going to give you output in the form of innovation, output in the form of idea only, output in the form of product. And accordingly, you proceed with your research. With these few words, once again, extending thanks to Jorhat Kendriyo Mahavidyalaya, extending thanks to all the members of the organizing committee. Moi aru beshi nokau iat because bahut speaker ase sobe kobo aru moi intentionally topicot nohomalo কবলৈ দিগদাৰ লাগিব এতিয়া আমাৰ প্ৰিপাৰেচন নাই তো বহুত দিন হল পাহৰিছো বস্তুখিনি বাট अगेन কম্পিটিশনাল বায়োলজি বায়োইনফৰমেটিক্স সেন্টাৰ যদি আপোনালোকে কৰিব পাৰে ভাল লাগিব মই ভাবো হিটু এটা আউটপুট হ'ব এটা ফুলফিলমেন্ট অফ অবজেক্টিভ এটু আমাৰ সেমিনাৰৰ হ'ব আৰু যদি ইয়াৰ পৰা কেইটামান পাবলিকেশন হয় আৰু প্ৰসিডিংস টু পাবলিশ কৰিব লাগে যদি প্ৰসিডিংস টু পাবলিশ কৰো মই জানো মই শুনিছো যেনেকা significant researchers, big contributors for আপোনালোকে মাতিছে ইয়াত যদি তাহতৰ সাজেশনের যোগেদি very easily you can have a convergence তিনিটা স্ট্রিম কনভার্জ কৰি কিবা এটা বস্তু ওলাব পাৰে হিখিনি যদি প্ৰসিডিংস হিচাপে পাবলিশ কৰে that proceedings should have a copyright তাৰো কপিৰাইট থাকিব গতিকে ইখিনি কৰি আপোনালোকে ফার্স্ট স্টেপ টু দিব পাৰে তাৰ পিছত লাহে লাহে প্ৰজেক্ট আনি আৰু ল্যাবৰেটৰী সেটআপ কৰি ৰিসাৰ্চ টু এনৰেজ কৰি যাবক ইখিনি আশা কৰি আৰু বেছি নকও সকলোকে মোৰ প্ৰণাম যাচি মই মোৰ বক্তব্য সামৰণি মাৰিছো
Board of Governors and the Vice Chancellor of Rabindranath Tagore University, Professor Mohite, my friend, and Professor Vaid. I just met him this morning. So, and other colleagues and dignitaries and students and staff. I'm very grateful and thankful to all of you for giving me this opportunity. Today, I'll be talking about green technologies. Actually, I changed my title a bit to make it more comprehensive because I was just having a chat with Professor Mohite, and he was telling that this is the 6th revolution. Because before that, we have several revolutions like metal revolution during the British times, when British became the world leader, and then several other revolutions came: IT revolution, biotechnology revolution, and now this sustainability and circular economy is the new concept which all over the world, all countries are adopting, because the industrialization has actually damaging the Mother Earth. This is the time where we have to wake up and cut down the carbon emissions and other pollutions, make it really green. So all the technologies are now adopting a green path, including chemical synthesis, everything. Okay, so this is a new era of science. So my talk is on this kind of thing. I will just take you through a journey where I show some certain technologies that are coming up. I cannot cover all the things now, but a few of them so that you will have a glimpse of what is happening in this area. Okay. So I am from University of South Africa, which is a premier university of central government of South Africa, directly funded by the Parliament of South Africa. This is our main campus. We have several campuses across the country, and also we have campuses across the continent as well. This is our main campus. This is our building, but the science campus is elsewhere. So basically, see, what is happening is we have to think about what is the carbon emissions, for example, how to reduce these carbon emissions is a key strategic area politically as well as scientifically. So if you see this graph, for example, you can see that the carbon emissions are decreasing a lot by probably in the coming years. Significant reduction is happening, and then the clean energy is taking over. Because of the heavy industrialization, we have too much electricity consumption. So we have various sectors actually of heavy industry and then electric vehicles and other civil buildings and so on. But if you see, there is a significant sector which is called data centers, because now, now because of the Google chat and all these things, everything is in your cell phone and everything is kind of cloud basis thing. So you have enormous big data centers from where you will be coupled to those data centers and you can access anything in the world through your cell phone or laptop. Okay, so this actually demands new data centers, and I think nowadays I heard that there's one big data center coming from Google to be set up in Andhra Pradesh. Similarly, there is another data center announced somewhere, I think in Maharashtra or someplace. So these data centers looks like a big investment, but then they are not good for environment because they consume lot of electricity and they liberate lot of heat. So when you consume lot of electricity, that electricity is produced by some fossil fuels or coal technologies, let us say, because the current energy production is dominated by the traditional methods like thermal and coal, etc., which is not good. And so the more electricity you consume, the more you will be producing carbon footprint. So essentially, our idea is to reduce electricity consumption. That means you need technologies to be developed in the line of saving energy or operating at very low power consumption. So in this regime, computers comes to a major role where you want to have computers working at very, very ultra low power, okay, and also high speed and high efficiency. So there are several things happening in this field. One is quantum computing, which is yet to come, but in parallelly there is another kind of memory systems that are coming. They are called RAMs, resistive switching random access memory. So I will tell a bit about it. And then I also tell about how certain chemical reactions can be done at very low power reactors, which we design. And then nowadays, everyone has cell phone and you have a lot of cell phone towers and you have too much microwave pollution. How to reduce that microwave pollution, how to have a handle on control on such a thing. So these three aspects I'll be discussing today with you guys. Yeah, you can see that ultimately the green energy is going to take over and it will be about 2000 terawatts by 2035 itself. Okay, so then in this green technologies, green computing is one of the major technology. So green computing is an important component in sustainable development because it will first reduce the electronic waste and also it will reduce the usage of electrical power tremendously. Okay, so essentially this kind of strategies is for this green computing. So if you see the market projection, it runs into billions of dollars in the coming years. Okay, I'm rushing so that I can finish in the given 20 minutes. So we have a huge BRICS project on this green computing, as well as we have bilateral projects with Italian government on this subject. So among the memories, you have several memories like flash drive, which you use regularly, and there are many upcoming memories like this. So we are now focusing on the ReRAM, which is a very simple memory and very low power consuming memory. So if you see the ReRAM parameters, it only consumes about nanojoule, 6 nanojoules per bit. 6 nanojoule per bit, that means it will never heat your computer at all. It's very, very, very low. You can't even feel it actually. So nowadays if you use laptop for a while or cell phone for a while, you will see that it is heated, okay? So now this kind of new memory is not going to heat your systems at all. Therefore it is it has high impact. Of course it matches with other performances like read time, endurance, retention time, all these things. It can compete with NAND flash drive. So there are other memories, but this is the upcoming memory. So the typical configuration is like this. You have a functional layer here in the middle, and then there's top electrode and bottom electrode. This is a switching phenomena. You have different varieties of switching. So it goes from low current to high current, or high resistance to low resistance. That's why it is called resistor switching. To do this research, you don't need big equipment. You guys, as a BSc honors fourth year project, you can actually establish such a small laboratory. You just need a spin coater to coat your functional layer on some substrate, and then you just need a small IV measuring unit, which doesn't cost much, maybe 5 to 6 lakhs rupees in Indian currency. And of course, SEM and AFM you can access through common facilities available in other big places like IIT, Kharagpur or some place, okay? So this is a very simple, easy laboratory to be established. So essentially, you take an organic layer, which is a polymer, which doesn't conduct electricity, but then there are conducting polymers also, for which Nobel Prize was awarded in, I think, in year 2000 or so, with Shirakawa and others shared that Nobel Prize. But right now we are working with non-conducting polymers or insulators. Then you introduce nanoparticles in that, and then it can switch to conducting, okay? So these are various configurations. You have a tandem layer kind of thing, and then you have ordered nanoparticles layer, and then a distributed nanoparticles. That distribution need not be exactly uniform. It can be non-uniform as well. So the green ReRAM has not only the beauty of, first of all, it is biodegradable. That means it won't add to the electronic waste when you want to discard the memory unit. Number two, it operates at ultra low powers. That means energy consumption is very less. That means it cuts down the carbon footprint. And then it has another beautiful thing, what is called, it can get into neuromorphic computing, okay? So our group has obtained a beautiful ReRAM which has switching magnitude of 10 to the power of 7 order of magnitude, which is a record, and we got patent all over the globe, American, European, Brazilian, Australian, Korean, Indian, everything, okay? So this has become a very highly it has become a very impactful thing. Now, why it is so impactful thing is it consumes very less power, and also it gets into neuromorphic computing. Before, I want to introduce to you what you mean by neuromorphic computing. This is a new thing happening. So the old computing, your laptops are operated on what is called one Neumann architecture, where you will have memory bits and then one single bus. So all the information comes through that bus. So you have a huge traffic. So it is like a bottleneck. It is like a neck between rest of India and northeast countries. small neck, okay? So therefore, it will have computational limitations in classical computing. The computing which we are using right now in our laptops or PCs. Neuromorphic computing is the other one where each bit has its own bus. That is the way our brain works. Our computing is neuromorphic computing. It does not have single bus, it has many buses. So that occurs in general in natural systems. For example, the right figure shows you different paths of information, so which is possible in ReRAM systems. So essentially you have a ReRAM bit which has top electrode and bottom electrode, which acts as pre-synapses and post-synapses, exactly like in neuromorphic system, neurons, and the applied voltage is an action potential, okay? So when you take I don't want to get into too much, just to tell you a rough idea of what is happening in a real system. You have many resistors, and they have a distribution with barriers, and then that barrier can be using an action potential. You can actually overcome that barrier and switch the material from high resistance to low resistance. But then there's a distribution of such resistances, so you will have a distributed system. So you switch from one distribution to another distribution, which leads to a kind of multi-level switching, okay, many switchings, okay. This is a little bit physics, so right now I don't want to do too much physics here. So this is what is called, when you apply the potential or sweep the voltage, you actually overcome the barrier, which is nothing but plasticity controlled by switching. So if you see here, we did with cow milk, a ReRAM with cow milk, okay, it's very interesting. So we are able to get this, the last figure you can see multiple switching is possible, and that is actually needed for neuromorphic computing. So we also applied for a patent for this. So we have carefully analyzed different varieties of milks with full cream milk, and then medium milk, cream milk, and totally fat-free milk. And then in a full cream milk, we don't have multi-level switching. That means it is not useful for neuromorphic computing. However, we are able to introduce multi-level switching even in full cream milk by incorporating certain nanoparticles like CDT and CDSC, coarse shell nanoparticles. This is another ReRAM extracted from certain plant leaves. We have developed so many ReRAMs with different plant leaves. Essentially, that means our ReRAM is a bio-ReRAM coming from bioresources, and it can be degradable in biosystem. That means it won't add to the pollution, and it operates at very low power. Of course, you have to analyze the conduction mechanisms to understand the physics, which we don't bother now. So to summarize on this, we have ReRAMs fabricated with various nanoparticles incorporated in biodegradable, bio-friendly materials. So we have understood the memory behaviors and conduction mechanisms, and then essentially we show that it operates at ultra low power consumption arena, and then it has multi-level switching, which is very important for neuromorphic computing. Okay. Then the next story is about the new thing coming up, what is called magnetoencephalography. It is like MRI, magnetic resonance imaging, which we all, each one, I think at least one of our family member would have done MRI these days. So in MRI we use magnetic resonance, so you use the nuclear spins or proton spins or carbon spins in our brain or body, and then you apply high magnetic field and turn them upside down and get the image, okay. This is called, basically it comes from nuclear magnetic resonance, and you advance it to the MRI. So there are at least 3 or 4 Nobel Prizes went into that field. Now, if you see the advertisements, they say that ours is 1.5 Tesla MRI. Nowadays, I see 2 Tesla MRI as well. So these fields are very, very high. So in some cases, high field is not good for my body. In some specific cases where some people would have some iron deposits inside the brain and so on. So in special cases, it is not good. But then this is a new era where you can actually imagine your brain with your own brain magnetic field. You can imagine your heart with your heart magnetic field. Okay. So the typical heart magnetic field is 10 to the power of minus 10 Tesla, and the typical brain magnetic Tesla is magnetic field of brain is 10 to the power minus 13 Tesla, and a typical sensitivity of a squid. Squid is a superconducting Josephson junction based device.
Streaming the RIP, Netflix, and Tron Ares.
Sorry for this. I think I must switch off. Yeah. Sorry for this. Yeah, so essentially you can use Josephson junctions based squid to actually develop such a thing. So on the helmet here you have many pixels. Each pixel is a squid. So with that you can actually imagine, okay. So to do that, when you do some physics of that, it comes out to be that the Josephson junction should be of nanoscale, very small size, okay. Then only you can actually sense the brain or heart or human organ fields. Okay, so then also other thing is quantum computing. The qubit needs Josephson junction to be very small. Josephson junction can work like a qubit. So in quantum computing, unlike the classical computing where you have 0 and 1 binary states, in quantum computing you have superposed states, okay. It comes from the fundamental quantum principle. So you have one state which can be expressed as a superposition of many states. That means you have inbuilt quantum cryptography. That means security. So therefore, and also speed. At one time you access all the states, okay. So because of its tremendous speed and security involved, quantum computing is an upcoming technology. And for that also you need a Josephson junction which is very small in the scale of nano size, okay. So there are 2 different Josephson junctions. A Josephson junction is a superconductor, non-superconducting superconductor junction, out of which we made using femtosecond laser technology. We made nanoscale Josephson junction. You can see the beautiful squares, Shapiro steps, and we actually developed a new lithography technique called S-junction, and then you can see that from the Josephson junction physics, the Coulomb energy should be of the order of the Josephson junction energy. Then only this can be used as a qubit. That requires the junction to be very small. So we have achieved this junction. We are able to patent it, and we are able to get patent in European Union, USA, China, I think almost all the countries across the world. Okay. Then this also operates at very low power. That's why the whole imaging, brain imaging or medical imaging can be done at ultra low power, less energy consumption. But MRI, the current MRI uses a lot of energy because you have to pump in amperes and amperes of current through the electromagnet there. The other thing is low energy catalysis, which our group is also working very seriously. So here, if you take the enzyme-based catalysis, enzymes are very expensive. Those who are working in biotechnology will know that enzyme is very costly. So enzymes will have this kind of foldings, and when you do catalysis, usually people use magnetic stirrers and so on, where the enzyme foldings can be disturbed. So the foldings are very important, and the foldings should not be disturbed. So you need a reactor where the enzyme is gently moved in the substrate. Okay, substrate means the solution where the reaction should happen. So what we did is we are able to attach the enzyme on a magnetic nanoparticle, and we moved the nanoparticle in a channel where using moving magnetic poles or changing magnetic poles. So magnetic poles changes with time, therefore it drags the nanoparticle automatically in the fluid. Okay. So this is a very simple experiment, but it yielded us great results, and we are able to I think almost two PhDs are out, and we have got a lot of patents on this. So why it became very successful is our ability to show that the particles move in the fluid without any turbulence. So we did particle shadow velocimetry and really showed that the particles are really in the no randomness actually. They move very gently in a streamlined motion. So there's no turbulence. That's why we are able to generate patents across the world. Then another field which we are working our group is how to control the microwave pollution in the environment. So to control, you must need something to absorb that pollution. So we have to design microwave absorbers, and then it should also have control that if I want the absorber to be on, it should be on, and if I want to switch off the absorber, I should be able to switch off, which we do with a very low field of the order of 100 Gauss or something. So the first time when we did it, we are able to obtain in half metallic manganites. Half metallic manganites are the materials where electrons are highly spin polarized, and only one particular spin will be moving across the material. Okay, that is called half metallic material because only half the spin, you have only one particular spin, either up or down, whatever. So then we also are able to see this, we are also able to design this absorber based on multiferrite materials, and then we are able to correlate. Actually this happens because of the spin canting, where spin canting means spins are not straight, they are slightly bent. So we are able to measure the canting, degree of canting using electron spin resonance spectrometry and understanding the interaction there. And then we also established this another microwave absorbers based on Husserl alloys. These alloys are from in collaboration with IIT Kharagpur. We got this material from them. So essentially you can design a low field tunable microwave absorbers to control the microwave pollution. These are various patents which we obtained in all the three mentioned fields in global patents. Our group, and we have visiting professors visiting from various countries, and we have collaborations across the world. So thank you for listening to me. So essentially now the green technologies are coming up with one single motivation to sustain our Mother Earth and the next generations. Okay, this is our motivation, and it is possible to do whatever industrial applications right now we have with a green philosophy. Okay, so with this I conclude my talk. I am open for your questions.